So for my ISU project, I did mine on rocket fuel and hydrazine. I'm Jonathan Lee, and this is my project. So a brief history of rockets in the old times. So in the 1st century AD, Chinese people had a simple form of gunpowder made from saltpeter, sulfur, and charcoal dust. They filled their bamboo bars with that kind of gunpowder to create fireworks, and they discovered that the gunpowder tubes can launch themselves by emitting gases. The first true rocket was born in 2032. So Chinese people used arrows in the war. It was called fire arrows. It was a simple form of solid propellant rocket, and they used it against their enemies. So in the 13th to 15th century, people had been experimenting with the simple forms of rockets, and people came up with a lot of ideas. One turned out to be the bazooka, which still exists today. And in the 16th century, a German firework maker invented a large skyrocket that carried a small skyrocket, which is kind of how it works right now. And that idea is still used today, and rockets are still like that today. So the modern rocket, in 1898, a Russian school teacher named Konstantin proposed an idea of sending a rocket to space. And in the 20th century, an American called Robert Goddard conducted practical experiment and made an analysis of how rockets will operate. And he succeeded first rocket flight in 1926. And in 1957, Soviet Union shockingly sent a satellite to space, and American quickly followed 1 year later. So, what is rocket fuel actually made of? Rocket fuel usually contains a lot of oxygen, or a mixture of fuel with oxidant. And another topic we're talking about, hydrazine, is one of the most used rocket fuel right now. So there are different kinds of rocket fuel: solid fuel, liquid fuel, gas fuel, and gel fuel. We'll talk about each of one of them except gel fuel, which is kind of still under progress right now, so we don't have much information and not used much right now. So all of them have their advantage and disadvantages, and they're used in different situations. So for solid fuel, obviously they're solid. They're made of large microscopic particles or bases, and they usually contain a mixture of solid oxidizer like ammonium nitrate with powders, energetic compounds, stabilizer, etc. Solid fuel is also used in military, so gunpowder is actually a form of solid fuel. So solid fuel is very easy to store at small size, because solid usually has smaller size than liquid, and obviously they don't go around that easily, so it's very easy to contain. But it's not as efficient as liquid fuel, and the combustion process causes a lot of crack, causes kinds of problem. One is like causing room temperature to raise, which can actually be a big problem. So some example of solid fuel are ammonium perchlorate, ammonium is actually one, and iron oxide. So for liquid fuel, one of the most used right now, there's liquid oxygen and kerosene. By the way, those are like together, not like actual and. They're usually used together. Same goes for liquid oxygen and liquid hydrogen. There's nitrogen tetroxide, hydrazine, and monopropellant. We'll focus ours mainly on hydrazine. So liquid fuel has a big history. It was already used in World War II. It was used in vehicles from Nazi Germany, even Russian, all of them. So most orbital launch vehicles uses liquid fuel, like cars and stuff. liquid fuel has a higher specific impulse than rocket fuel. Basically means they're more efficient. Liquid fuel are easy to shut down, restart, and there's a lot of choices, a lot of oxidizer to choose from, unlike most other fuels. But the drawback is that the liquid fuel is very hard to store because they have high reactivity and with common materials, and a lot of liquid fuel have high toxicity, including hydrazine, which we'll talk about later. So gas fuel, so they usually involves compressed gas, so they don't take much space, and it's generally not used much because it's very hard to contain. So hybrid rocket is one of the only few rockets that sometimes use gas fuel. They usually don't always use gas fuel. They usually use solid and a fluid fuel, which is liquid or gas fuel. And gas fuel, like liquid, it's very easy to shut down, restart it, do all kinds of stuff, but it's just extremely hard to contain because it's gas. So gel fuel, it's really flammable. We know that. It is used to give a propellant with low vapor pressure. It is easy to store as efficient as liquid fuel. It's very dangerous, and it's still more of a work in progress, so we're not talking too much about it. So time to move on to hydrazine. So the chemical formula is N2H4. It is a base. It is colorless, flammable liquid with an ammonia-like odor. In fact, it's a lot like ammonia in many kinds of aspects. Hydrazine is highly toxic and dangerously unstable unless handled in a solution. So, by it alone, it's extremely hard to deal with, extremely dangerous. Usually, you need to add it into another solution. So, for the molar mass, it's 32.0452 gram per molar. So the density is 1.02 gram per cubic centimeter. The boiling point is 114, and the melting point is 2. So why is hydrazine a good rocket fuel? So here's a fuel chemical reaction. So the main function of hydrazine is emit a lot of gas, and you can see in those formulas, it's very easy to make it combust or do chemical reaction, and they can emit tons of gas with a small volume. Like you can bring a very small volume and a lot of gas, a lot of nitrogen, a lot of hydrogen will go out. So the first two reactions you can see are very exothermic, meaning they lose energy, meaning they'll emit energy, which will push the rocket. And the third reaction is endothermic, meaning the outcome will have lower energy, so it'll reduce the temperature for the final result if that's a problem, and it'll produce a lot of molecules. So the advantage of hydrazine, it is a liquid, so liquid fuel, and it's very efficient inside the liquid fuel. So it's very efficient. It has high freezing point, so sometimes it can be a problem like space. Sometimes it's very cold, so if you need something that don't freeze, this is very useful. Strong reducing agent. It's good reacting to other things and reduce everything. And its main function, a good blowing agent. It blows a lot of stuff. So how is hydrazine formed? How do they make it? There's multiple ways to form hydrazine. So one of them is oxidation by chloramine from hypochlorite on ammonia, which is this equation you see. So, and there's oxidation of urea by hypochlorite, which is that. and oxidation by oxidizing from peroxide on ammonia. By the way, so you might be confused where it says like H2N and H2. It's basically another written form of hydrazine because N and N are bonded and stuff. So hydrazine's effect on human. So some effect will be irritation of eyes, nose, throat, temporary blindness, dizziness, headache, nausea, pulmonary edema, seizures, and coma. So hydrazine, as we said, it's toxic, and it's toxic to blood, kidneys, lungs, and the nervous system and mucous membranes. Any contact with it can cause tissue damage and burns. Inhaled will damage the respiratory system, and if it contacts any other system, then these will get damaged as well. And if you have contact it too much, having it too much, it can kill you. So hydrazine's effect on the environment. If it is releasing air, it will be degraded like most things. So in the soil, it can turn liquid into gas, it evaporates into the surface. Surprisingly, it doesn't cause too much environment damage because it's easily decomposed by air. It can mix into air very easily. So it's easily decomposed, so it doesn't cause too much bioaccumulation. You can see it in the chart here. It has been increasing lately though, because we are using a lot more. All right, that's the end. Thank you very much. See you next time.